What if I told you that the table in front of you doesn't exist when you're not looking? That your phone, this video, even your own body, might only exist because your consciousness is observing it? What if reality itself is merely a construction, a collaborative hallucination we all agree upon? What if the universe is more like a thought than a thing? Welcome to the rabbit hole where quantum physics and philosophy collide. Today, we're asking the most fundamental question possible. Is reality real? Before you dismiss this as some kind of pseudo-scientific nonsense, let me assure you, we're not talking about mysticism or magic. We're talking about Nobel Prize-winning physics, centuries of philosophical inquiry, and why you, yes, you, might be the unconscious architect of the universe you inhabit. Think about it. Right now, you believe you're watching a video on a screen. But what if both the video and the screen only materialize because you're perceiving them? What happens when you look away? Buckle up. We're about to bend your mind in ways you never thought possible. To understand why reality might not be what it seems, we need to start at the smallest possible scale, the quantum realm. For centuries, scientists believed in what we call classical physics, a deterministic universe where objects have definite positions, follow predictable paths, and exist independently of observation. It's the physics of Newton's falling apples and Einstein's elegant equations. But in the early 20th century, something extraordinary happened. Scientists peered into the subatomic world and discovered that reality breaks down at the quantum level, the realm of electrons, photons, and other subatomic particles. The rules change completely. Particles don't behave like tiny billiard balls. They act like probability waves, smeared across space and time until someone looks at them. This isn't just a strange theory. It's been proven in countless experiments. When scientists fire electrons through two slits, they create an interference pattern, like waves rippling through water. But here's the mind-bending part. When they set up detectors to observe which slit each electron travels through, the interference pattern disappears. The mere act of observation changes how the particles behave. Let that sink in. The act of looking, of conscious observation, literally changes reality at its most fundamental level. This phenomenon is part of what physicists call the observer effect. Think of it like a cosmic game of peekaboo. The universe only shows you its building blocks when you're watching. When you're not looking, they exist as probabilities rather than concrete realities. Classical physics says the world is like a precision clock, predictable, mechanical, and objective. But quantum physics? It's more like a dreamlike casino where probability rules and certainty disappears. This led to Erwin Schrödinger's famous thought experiment about a cat in a box with a radioactive trigger that might or might not kill it. According to quantum mechanics, until you open the box and observe the outcome, the cat exists in a superposition of states, both alive and dead simultaneously. I know what you're thinking. Cats can't be both alive and dead. That's absurd. And that's exactly the point. Quantum physics reveals a reality that defies our intuitive understanding. But here's where it gets truly fascinating, and where philosophy enters the picture. Why does observation collapse these probability waves into definite states? What constitutes an observation? Is it the measurement equipment? Is it the conscious mind interpreting the results? Or is there something even deeper happening? Consider this. In the Copenhagen interpretation of quantum mechanics, long considered the standard view, reality doesn't exist in a definite state until measured. Physicist Niels Bohr summarized it this way: if quantum mechanics hasn't profoundly shocked you, You haven't understood it yet. But there are other interpretations too. The many worlds theory suggests that every quantum possibility creates a new universe, meaning there are infinite realities where every possible outcome occurs. Then there's the pilot wave theory, which suggests particles do have definite positions, guided by invisible waves we can't detect. The honest truth? Nobody knows which interpretation is correct. The math works perfectly, but the meaning behind it remains one of science's greatest mysteries. Long before quantum physics revealed reality's strange nature, philosophers were already questioning whether the world really exists as we perceive it. Let's travel back over 2,400 years to ancient Greece. Plato, student of Socrates and teacher of Aristotle, proposed his famous allegory of the cave. Imagine prisoners chained in a cave since childhood, facing a blank wall. Behind them burns a fire, and between the fire and prisoners is a raised walkway where people carry objects. The prisoners see only the shadows of these objects projected on the wall, and mistake these shadows for reality itself. Plato's point was profound. What we perceive as reality might be merely shadows, imperfect representations of a deeper, truer reality we cannot directly access. Fast forward to the 17th century. French philosopher René Descartes took skepticism to its logical extreme. He asked, "What if an evil demon was systematically deceiving me about everything I perceive? How could I know what's truly real?" Descartes concluded that the only thing he could know with absolute certainty was his own existence as a thinking being. Cogito, ergo sum. I think, therefore I am. Everything else, the external world, other minds, even his own body, remained open to doubt. In the 18th century, Irish philosopher George Berkeley proposed an even more radical idea, that objects exist only when perceived by a mind. According to Berkeley, there is no material world independent of perception. When no one is observing an object, it continues to exist only in the mind of God. Berkeley's contemporaries thought this was absurd. Samuel Johnson famously refuted Berkeley by kicking a stone and declaring, "I refute it thus." But was Johnson missing the point? After all, his perception of the stone's solidity doesn't prove its independent existence, only his experience of it. Then came Immanuel Kant, who proposed that we never experience the thing in itself, what he called the noumenon. Instead, we only experience phenomena, reality filtered through our cognitive structures, space, time, causality. These might not be features of reality itself, but rather the lens through which our minds inevitably perceive reality. What's remarkable is how these philosophical insights foreshadowed quantum physics centuries before anyone split an atom. If reality depends on observation, are we just perceiving a shadow of a deeper reality, just as Plato suggested? Is Berkeley's observer-dependent reality vindicated by quantum mechanics? Are Kant's phenomena similar to quantum probability waves that collapse into definite states only when observed? When quantum mechanics emerged in the early 20th century, it didn't just challenge our understanding of physics. It reopened ancient philosophical questions about the nature of reality. Albert Einstein, despite helping birth quantum theory, couldn't accept its probabilistic implications. He famously objected that God does not play dice with the universe. Einstein believed in an objective reality that exists independently of observation. He once asked Abraham Pace, "Do you really believe the moon exists only when you look at it?" Einstein couldn't accept that reality might be observer-dependent. Bohr's response was subtle but profound. We can't talk about reality without talking about measurement. In other words, whatever reality might be in itself, we can only know it through observation. And observation inevitably influences what we observe. This wasn't just a scientific disagreement. It was a philosophical one. Einstein held what philosophers call a realist position. Reality exists objectively, independent of observation. Bohr, meanwhile, represented an anti-realist or instrumentalist view. Science describes our experiences and measurements, not necessarily an underlying reality. Their debates culminated in the Einstein-Podolsky-Rosen paradox, where Einstein tried to prove quantum mechanics incomplete by showing how entangled particles could communicate faster than light, what he derisively called spooky action at a distance. Decades later, physicist John Bell developed a mathematical theorem to test Einstein's objections. And when experiments were finally conducted in the 1980s, they confirmed quantum predictions. Einstein was wrong. Quantum entanglement is real. But what does this mean? Can particles really influence each other instantaneously across vast distances? Or does this suggest that, at some deeper level, separation is an illusion? That space itself might be emergent rather than fundamental? Physicist John Wheeler, who coined the term black hole, proposed that we live in a participatory universe where observer and observed are inseparably connected. He suggested that conscious observation might be central to reality's existence. Wheeler even proposed the delayed choice quantum eraser experiment, which suggests that our observations now could retroactively determine what happened in the past. If true, this would challenge our most basic assumptions about causality and time. Think about the implications. What if consciousness itself, your consciousness, isn't just passively observing reality, but actively participating in creating it? What if the act of observation doesn't just reveal reality but helps shape it? If quantum physics makes reality seem strange, here's a hypothesis that might explain why. What if reality is a simulation? Oxford philosopher Nick Bostrom formalized this idea in his influential 2003 paper. His argument is probabilistic. If advanced civilizations could create simulated realities indistinguishable from base reality, and if they would create many such simulations, then simulated realities would vastly outnumber the single base reality. Therefore, purely as a numbers game, we're more likely to be living in a simulation than in base reality. It's simple probability. Tech entrepreneurs like Elon Musk find this argument compelling. After all, we already create simulated worlds in video games. Given enough technological advancement, wouldn't these simulations eventually become indistinguishable from reality? If we are in a simulation, quantum weirdness suddenly makes sense. Quantum indeterminacy could simply be the system's rendering limit. Like pixels appearing only when you zoom in or processing power allocated only where attention is focused. Consider a glass. In a video game, the program doesn't calculate every water molecule when no player is looking at it. That would waste computational resources. Similarly, perhaps quantum particles exist as probability waves until observation forces the system to render them in specific states. The simulation hypothesis also offers a potential explanation for the fine-tuning of physical constants. If the universe were programmed, these precise values would be parameters set by the programmers. Of course, this raises uncomfortable questions. If we're simulations, do we have free will? Are we running on someone else's computer? And could they shut us down? But here's a more optimistic interpretation. If reality is computational in nature, perhaps consciousness itself is the algorithm running the simulation from within. Maybe we're not just characters in someone else's simulation. We're co-creators of our shared reality. We've circled around a central mystery. What is consciousness? And what role does it play in the creation or perception of reality? Consciousness remains one of science's greatest unsolved puzzles. We experience it directly. The feeling of being you, watching this video right now. Yet we struggle to explain what it is or how it arises from physical processes. Some physicists and philosophers have proposed that consciousness and quantum mechanics might be fundamentally connected. Physicist Roger Penrose and anesthesiologist Stuart Hameroff developed the orchestrated objective reduction theory, suggesting that quantum effects in brain microtubules might generate consciousness. Others, like philosopher David Chalmers, have proposed panpsychism, the idea that consciousness might be a fundamental property of the universe, present in some form at all levels of reality. If consciousness is indeed fundamental rather than emergent, the observer effect in quantum mechanics takes on new significance. Perhaps consciousness doesn't just measure reality. It participates in creating it. This brings us to the anthropic principle. The observation that the universe appears finely tuned for conscious life. Is this a cosmic coincidence? Natural selection of universes? Divine design? Or something stranger? Like a universe that requires conscious observers to fully exist? Wheeler proposed what he called the participatory anthropic principle. The idea that observers are necessary for the universe to exist. In his words, the universe gives birth to consciousness, but consciousness gives meaning to the universe. This creates a kind of cosmic loop. Consciousness emerges from the universe, yet the universe requires consciousness to determine its properties. It's not unlike the chicken and egg problem, but on a universal scale. Modern theories like integrated information theory propose that consciousness arises from complex information integration. If true, could the universe itself possess a kind of consciousness? Are we fragments of a greater cosmic awareness? And what about you, the one experiencing this moment? What if your consciousness isn't just perceiving reality, but participating in a grand cosmic collaboration that creates reality? What if we're all entangled observers in a universe that requires observation to exist? Let's explore another profound implication. If quantum events introduce genuine randomness into the universe, what does that mean for free will? In a purely deterministic universe, where every effect has a precise cause, free will would be an illusion. Your choices would merely be the inevitable result of prior causes stretching back to the beginning of time. This deterministic view dominated classical physics. If you knew the position and momentum of every particle in the universe, you could, in theory, predict the entire future and retrodict the entire past. But quantum mechanics introduces fundamental uncertainty. If some events are truly random at the quantum level, does this create space for free will? Not necessarily. Randomness isn't the same as choice. If your decisions were merely the result of random quantum fluctuations in your brain, would that really be free will in any meaningful sense? Some philosophers propose compatibilism, the idea that determinism and free will can coexist if we define free will as acting according to our own desires without external constraint. Under this view, you're free, even if your desires themselves are determined by prior causes. Imagine two versions of you. One lives in a deterministic universe. Your brain is a complex machine, and every choice is the inevitable result of prior causes. The other lives in a quantum universe. Your decisions are influenced by genuinely random quantum events in your neurons. Neither scenario matches our subjective experience of making choices. Neither feels like what we intuitively think of as free will. Yet what if there's a third possibility? What if consciousness itself, your awareness, plays an active role in collapsing quantum probabilities into actual events? What if your choices aren't just determined by prior causes or random quantum fluctuations, but represent a third category of causation? Conscious choice? This would mean you're not just passively experiencing reality. You're actively participating in creating it through your choices. You're not just in reality. You're creating reality with every conscious decision. Though speculative, this perspective suggests that consciousness might be the universe's way of choosing among quantum possibilities. Your awareness might be how the universe transforms probability into actuality. You might be thinking, this is all fascinating, but does it actually matter in my daily life? Does quantum reality change how I should live? I believe it does. In profound ways, understanding reality's quantum and philosophical dimensions can transform your perspective on existence itself. First, it invites intellectual humility. If the greatest physicists and philosophers of our time can't agree on the nature of reality, perhaps we should hold our own certainties lightly. The universe may be stranger than we can imagine. Second, it suggests interconnection. Quantum entanglement implies that separate objects are illusions. At a fundamental level, everything may be connected in ways we're just beginning to understand. Third, it highlights the power of observation. If observation helps shape reality at the quantum level, perhaps our attention and focus are more powerful than we realize. What we choose to observe in our lives, our relationships, our world, may subtly influence what manifests. Fourth, it opens space for possibility. If reality isn't fixed and deterministic, but fluid and partly observer-dependent, perhaps the future holds more possibilities than we've assumed. And finally, it suggests that consciousness itself, your subjective awareness, may be more fundamental to reality than we've recognized. Your experience isn't just an accidental byproduct of physical processes, but might be central to how reality functions. These insights don't just change how we think about reality. They can change how we live within it. They invite us to be more conscious participants in our experience, more aware of how our observations and interpretations help shape the reality we inhabit. As we near the end of our journey, let's revisit the big questions we've explored and consider some possible answers. 1. Is reality observer-dependent? Quantum physics suggests that, at least at the subatomic level, reality doesn't exist in a definite state until measured. Whether this extends to the macroscopic world remains debated, but it's clear that observation plays a more fundamental role in reality than classical physics assumed. 2. Is reality simulation-like? The simulation hypothesis offers an intriguing framework for understanding quantum weirdness and universal fine-tuning. While unprovable, it reminds us that reality might be computational or information-based, rather than simply material. 3. Is consciousness fundamental to reality? Several interpretations of quantum mechanics suggest consciousness may play a role in collapsing quantum possibilities into actualities. While controversial, these views challenge the assumption that consciousness is merely an epiphenomenon of physical processes. 4. Do we have free will? If consciousness can influence quantum outcomes, perhaps our choices represent a form of causation beyond strict determinism or randomness. This wouldn't prove traditional free will, but it would suggest a more participatory role for consciousness than materialist views allow. So where does this leave us? 3 possibilities emerge. 1. Reality is subjective, shaped by observation and perhaps dependent on consciousness. 2. Reality is intersubjective, a kind of collective creation or agreement among conscious entities. 3. Reality transcends our categories, neither wholly objective nor subjective, but something our concepts can't fully capture. Which do you believe? There's no consensus among physicists or philosophers. The honest answer is, we don't know. But perhaps not knowing is itself valuable. Perhaps the mystery invites us into deeper wonder and more careful observation. As physicist Richard Feynman said, "I think I can safely say that nobody understands quantum mechanics." And maybe that's okay. But before we conclude, let's confront one last, mind-bending implication. In this moment, your consciousness is engaged with these ideas. You're not just passively receiving information. You're actively interpreting it, making meaning from it, integrating it into your understanding of reality. In that sense, you're not just learning about reality. You're participating in creating it through your conscious engagement. Your awareness is where these abstract ideas become real. We've traveled from quantum physics to ancient philosophy, from the double-slit experiment to the simulation hypothesis, from the nature of consciousness to the question of free will. We've encountered more questions than answers, more mysteries than certainties. But perhaps that's the point. Perhaps reality isn't something to be finally figured out, but continually explored. A collaboration between the universe and those conscious entities, like you and me, trying to understand it. As quantum physicist Werner Heisenberg wrote, "What we observe is not nature itself, but nature exposed to our method of questioning." Different questions reveal different aspects of reality. No single perspective captures the whole. So, what's the takeaway from our exploration? I'd suggest this. Reality is richer, stranger, and more mysterious than our everyday experience suggests. The table in front of you, the screen you're watching, the person you see in the mirror. These may be more fluid, more interconnected, and more observer-dependent than we typically assume. And perhaps the greatest mystery is you, the conscious observer experiencing this moment. Whatever reality ultimately is, you are not separate from it. You are an active participant in the grand cosmic dance where subject and object, observer and observed, mind and matter meet. Thank you for joining me on this journey through the quantum nature of reality. If this video expanded your mind or sparked new questions about existence, please hit that like button and subscribe for more philosophical explorations of life's deepest mysteries. And remember, reality might be what you make of it, or what we make together. Until next time, keep questioning, keep observing, and stay curious about the nature of existence itself.